Evaluate the integral of x cubed cos x dx. Now, here's the thing. Look up, please. Limits 3 and 6 and 0. Here's the thing here. Please listen. Here's the thing here. Normally, if you give me a question, the first thing that should come to your mind is substitution. That's the first that comes to mind. I will ask myself, is there anything I can substitute such that it will cancel out something here, as in the first case I did? In this case, literally nothing. If u is cos x, if I differentiate cos x, I'll have minus sine x. It's not cancel this. Fine. Let u be x. If u is x here, if I differentiate x, I'll have what there? 1. It's not cancel x cubed. Okay, let u be x cubed. If u is x cubed, if I differentiate x cubed, what do I get there? 3x squared. X squared cannot cancel this. In essence, this question is not a substitution question. That's how to think about it. If it's not substitution now, this form, if you're conversant with integration, it becomes integration by what there? By parts. By parts. In integration by parts, what's your formula? It has a formula. What's the formula? It has a formula. What's the formula there? Integral of okay. By part formula is the integral of u dv is equal to what there? uv minus integral of what there? v du. This is the integration by part formula, also there online. That's the formula. In essence, if I'm doing integration by part, I will take one of the term as u, take the second term as what there? dv. All right, I would come here, I would say let u be equal to, which of this term will be u? This one here, u dv. U is x cubed. All right, what is dv? This one here, cos x. Please, this formula, if you have to memorize it, no problem. So you have u dv, it's equal to, if I look at this same u appears here, but in this case here it's uv, not u dv. If I have u, I want to get du over dx or du, it becomes differentiation. I will differentiate this to get du over dx or du. If I have v, I want to get dv, I'll differentiate v. If I differentiate v, I'll get what there? dv. The question now is this: if I have dv, I want to get v, what do I do? I'll integrate. So look up, please. When you get u and you get dv, for u, you've gotten u, see that you need a value for du later. You need this value. In essence, for me to get the u, I have to do what there? Differentiate. What is du? Du, let me write it up here. From here, du would be, what value do I get when I differentiate this value here, which is this one here? Differentiate x cubed, what do you get there? 3x squared. That's the u. For v, to get the value of v, I will integrate the v. Please, if I integrate cos x, what do I get? Hello? If I integrate cos x, what do I get? Sin x or minus sin x? If I listen. If I differentiate cos x, I'll have minus sin x. If I integrate cos x, I'll have what there? Sin x. So v is equal to sine of x. So it's quite simple. For these two, call one of them u, which is this. Call this dv. Try to get du. How do you get du? Differentiate u, you get du. This one is dv. You have dv. How do you get v itself? Integrate it. If I integrate cos x, I'll have sine x. Using integration by parts, please watch this. Using integration by parts, the integral, listen again, listen. Whenever you're solving definite integrals, it's okay to leave out this one for now. That means integral of x cubed cos x dx. It's okay to leave out the limits for now. Let's just try to get this value. When we get the value, we can bring back the limits. This will be equal to, look up please. We said, oh, let me write the formula. Using integration by parts, you have that the integral of u dv is equal to uv minus integral of v du. Impute values. I have the integral of this. If you talk, you miss it. Focus. If you talk, you miss it. Focus. This is x cubed cos x dx. It's equal to what's u? X cubed. What's v? Sine x minus integral of what's v? Sine x. What's the u? Sine x times 3x squared. Now look at this and look at this carefully. This will give you this value. Look up please. This will give you x cubed sine x. I said whenever you have a constant in integration, take the constant outside the integral sign. That becomes minus 3 integral of, if I take this constant outside the integral sign, I'll be left with sine x times x squared. Of course, sine x times x squared becomes what? Huh? Sine x times x squared gives you what? Sine x times x squared gives you what? Sine x cubed. Sine x times a. What do you have here? This and this are the same thing. If this would give you a sine x, the idea is that this one comes this way, a sine x. This one comes this way. What do you have there? So this 3 comes outside integral sign. This becomes x squared sine x. Let me show you the crazy thing about this question. So look up. Let me show you the crazy thing about this question. It's a question that is usually pregnant. And by that, I mean a question that will give birth to other questions. So listen, watch this. We're saying that my initial question, the integral of x cubed cos x dx, which is this, will lead us to the answer should be equal to x cubed sine x minus another integral again. This question that they gave to us, in solving it, I now have another question. All I do, I'll pick up this one again and solve again from the very beginning by parts. For some reasons, this one too might give us another question. So listen. You pick up, I will say pick this one here, the integral of x squared sine x dx, and integrate by part again. Integrate by parts. And integrate by parts. What do I get? Look up, please. This becomes the integral of, okay, for by parts, we need u dv, du, and v. What's u here? Let u. So I'm basically repeating the same thing here. Let u in this case be what there? X squared. What's the v? What's the v there? Sine x. Okay. After u and the v, I still need du. I still need v. How do you get du? Du, please, to get du, am I supposed to differentiate or integrate? Differentiate which of the terms there? If I differentiate x squared, what do you get? Du is 2x. That's it. We have dv. I want to get v. To get v, am I differentiating or integrating? Integrating which of the terms there? If I integrate sine x, what do I get? What is the integral of sine x? Huh? You have joined the bandwagon. Minus cos x, minus cos x. If I ask you why it's minus cos, can you tell us why it's minus cos x? So listen. Next week Saturday, well, we'll just do a vote. I don't know. We agreed to do chemistry practical online, but they moved it. Listen. We agreed to do chemistry practical online, but we'll do a vote on the group. If they say we should do a physical, they will do it in 2 parts. It will be both practical and theory revision at once. If there's, but we'll focus on the practical when we're done. Focus on the theory. It's not that plenty, so I can combine both organic chemistry practical as well as the theory question too in one Saturday. I can possibly, but until then, listen. Those ones you can come without prior knowledge. That's fine. But you see these ones here, you have to have a bit of knowledge. But anyways, back to base. Let me show you something. Look up. If y is equal to cos x, what is dy over dx? Differentiate cos x. What do you get there? You have minus sine x. So listen. If I now integrate sine x, what do you have there? Hold on. If I integrate minus sine x, I'll have the what there? Cos x. In a case where the minus is not here, if you now integrate sine x, what do you do here? Bring the minus here. It becomes minus cos x. That's it. Please check up these things, please. I know I listed these things for you before online. Go and check them up. If I differentiate sine x, I have cos x. If I integrate cos x, I have what there? Sine x. If I differentiate cos x, I have minus sine x. If I integrate sine x, I have what there? Minus cos x. Let's take these values here and put them again. Using integration by parts. Using integration by parts. What do I have there? I will have that the integral of u dv is equal to what there? uv formula minus integral of what there? v du. Please, what's u? X squared. That is x squared uv. What's v? So please, can I call this minus x squared cos x? Let's save ourselves time. Is that okay? Please, uv means u, that's x squared times v minus cos x. If x squared multiplies minus cos x, the minus comes out first, minus, and then this one next, x squared, and then this one x, cos x. Are we good? Okay. Minus the integral of v du. What's v? Please check. What's v? Minus cos x. That's v. What's the u? Du is 2x. So you have this. Please simplify this. What do you have here? would have that this one here, the integral of x squared sine x is equal to, what do I have here? Minus x squared cos x minus minus plus. Now listen, this is cos x multiplying 2x. What do we know here? What we know here is that a constant will always go outside the integral sign. So the constant 2 goes outside the integral sign. I'm left with cos x times x. Please, cos x times x, what do you have there? That becomes x cos x. Don't be shouting minus. We've done minus minus. Give us what there? Plus. So wait to watch this. Watch this. See. Just hold on. Watch this. Hold on. Watch this. See my first question. They gave me this question here. In trying to solve this question, for some reason, using by parts, I now arrive at a second question, which is this. In trying to solve the second question, that's this. For some reason, I now arrive at the third question. I will pick this and integrate by parts. So look up. Look up. At this juncture, please look up. It's okay, look up. Especially the engineering guys, look up. At this juncture, what to do here is repeat. I don't know, it looks lengthy. Length is not equal to hard. You are basically repeating the whole thing again and again. It's just repetition, no big deal. Come here again, pick up this one here. So I would say pick what there? Integral of x cos x, and do what there? And integrate by parts. All right, let's work on this. In this case here, what you? Let it be equal to what there? X, okay. That's this. What is the v? Cos x. I've gotten u. I need to find the u. To get the u, that means I am differentiating. Please differentiate the u term. That differentiate x. Differentiate x. What do you get there? 1. I have the v. I need to find v. To get v, I have to do what there? Integrate. Please integrate cos x. What do you get there? Let's put this into the formula and see what we get. Using integration by parts. Integration by parts. What do I have there? The integral of u dv is equal to what there? uv minus integral of what there? v du. Please, let's put in values. What's u? In this case, x. What's v? X sine x minus integral of what's v? Sine x. What's the u? 1. That means I am almost good. Almost good. Almost good. That means the integral of, where's that man there? This one. The integral of x cos x is equal to this x sine x minus, please, sine x, sorry, minus integral of sine x times 1 gives you what there? Sine x. What do you observe again? I am supposed to say pick this one and solve, but integral of sine x is what? Minus cos x. So it has an answer. We are done. So this is equal to, this becomes x sine x minus Integral of sine x gives you what there? Minus cos x. The luck we have here is that there's no x term here. If not, would have repeated. This will be equal to, please let me rewrite this. Let me rewrite this. This is equal to, so this is equal to x sine x minus the integral of sine x is what? Minus cos x. Please combine this. What do you have there? X sine x plus cos x. I am done with the integration part. I am not done with the limit part. Hold on, hold on, hold on, hold on. In fact, I'm not even done with the integration part. Copy down. Let me show you something. So when it comes to this part, you can skip in peace if you want to. This is baby calculus. So when you come to year 2, you will know we are playing here. Engineering guys, talking to you guys now. Please, let's finish up so we can do a question on functions, please. Let's finish up so we can do a question on functions, please. So the mass is do your best, Abby. I want to clean, please. Please, I want to clean, please. Now, please look at this. This is how to combine your several different answers. Please look at this. I don't know why I brought this up. I want to keep this for last, but I just brought it up. Sorry, I brought it up over here. But look up. How do you combine your answer? Don't forget that our very first question was this, which was the integral of x cubed cos x dx. And what's your answer? Here. Your answer there is x cubed what? Sine x minus 3. Look up, please. Look up. Look up. Minus 3 times anything you get after you do this integral. We've done this integral. Let's find it. See it here. When I do this integral, what's my answer here? So this thing you have here will now come here. We are saying minus 3 times anything you get when you do the integral of this one here, which we've done here. See your answer. So bring this thing here this way. So this into what there? 3 into, let me use square bracket, 3 into minus x squared plus, sorry, x squared cos x. X squared cos x, plus 2 times what? 2 times anything you get when you do integral of what there? X cos x. Do you have that value? When we do integral of x cos x, what do you get there? A final answer. This one here, bring it here. So plus 2 times anything you get when you do the integral of x cos x. When we do that, we have x sine x plus cos x. This This is our answer in an unsimplified form. Number two, I have not included limit of 6 and 0. So look up. See how, look up now, look up, look up. The thing is this. This is, hold on now. This is giving you that deja vu of what engineering looks like. Let me tell you how we learned engineering. Go and ask your level 200. Those guys in year one, when you come to UT, I'll tell you. When you come to engineering class, we don't understand what we are doing, but we know the process. Now, I'm telling you now, I'm not kidding. When you come to level 200, level 200 is not when you enter class, they teach you understand. You don't understand. You just know the process. Before you understand it, you have to go back and repractice it. That's how it is. So it looks easy and hard at the same time. But then understand what we did. We took the first one, we integrated. It will give you another second one there. Take that one, integrate. It will give you a third one there. Just continue until you get an answer. When you get your answer, know how to put them inside again, like this. And that's it. Let's expand this. Or should we stop here? Let's expand this. Okay, say, listen now. Let's expand this, please. Look up. Expand is what you have here. This is equal to, please watch this. This is equal to, what do you have here? X cubed sine x. Use minus 3 to multiply this and this. So look up, please. Minus 3 times, minus gives you what there? Plus 3 times x squared, 3x squared plus x. Minus plus minus 3 times 2, 6 into all of this. X sine x plus cos x. You have this. So I've expanded this. Look up, please. Use minus 3 minus plus 3 times this is this. Minus plus minus 3 times 2, 6 multiplies this. You have this. Again, I say to use 6 to multiply 2. That's equal to, from here, what do you have there? X cubed sine x plus 3x squared cos x minus 6 into this. What do you have there? Minus 6x sine x minus times plus minus 6 times cos x. 6 cos x. Please check any like terms. Any like terms? Don't say yes. What's the like term? So you see sine x, you say you shout yes. So listen. That means the integral of x cubed cos x dx is equal to what I have there. Is equal to what I have there, which is what there? X cubed sine x plus 3x squared cos x minus 6x sine x minus 6 cos x. This is my answer. You know the funny thing? If you're good with differentiation, go back home, do differentiation for this. You have this answer. Try it. Go back home, say, let y be equal to this. For this, I'll use product rule. For this, another product rule. For this, another product rule. For this, when you do this, you must have this answer. To give this answer here. Try it. I know you're not try it. Back in those days, see, Back in those days, right? When they say try, this is what we'll go and do it. You see that 10 to cancel, at the end you have this answer as as unreasonable. Like, how can this plenty thing differentiate to give you this? Go and try it. You see terms canceling out, you be left with this. What we've done here, we have just differentiated. In the question, you were not asked to differentiate. You have to find what there? Limit. So listen, if you now put, look up, if you now put this as 6x0 and x cubed cos x dx, how do you solve this? It's simple. In this question, wherever I see x, I'll put what there? 6 minus, repeat this. Wherever I see x, I'll put what there? 0. What do I mean? We'll take all of this. Wherever I see x, put the upper limit, 6 minus, repeat it again. Wherever I see x, I put, this becomes what there? Upper limit 6. So what do you have here? 6 cubed, sine 6 plus 3 times 6 squared cos 6 minus 6 times 6. Please, someone be punching this for us, please. Sine 6 minus 6 cos 6. This is for upper limit. Minus for lower limit. Do the same thing, but in this case, use 0. Wherever I see x here, put 0. What do you have there? 0 cubed, sine 0, plus 3 times x squared, 0 squared, cos of 0, minus 6 times 0, sine of 0, minus 6 cos 0. You have this. So the 6 versus the zeros, the same equation. That's all. Please, to save my time, could you give me can somebody give me the final answer? Is it possible? Or hold on, is it total answer all for 6? Which of them? For the 6. Okay, for 6, what do you have there? One what? 120.25 minus, for the 0, your answer will be minus 6. Minus 6, right? Yes, now look at it. This is 0 times this. That's 0, 0, 0. Cos 0 is 1. Minus 6 times 1 gives you what there? Minus 6. This into, this minus. Please punch all of this. Your answer will be minus 6. If I add this up, this becomes 120.25 minus plus 6. Combine this, what do you have there? 126 point what there? 25. This is your answer, ladies and gentlemen, for your 10 marks.